Okay, example 4. Example 4 is slightly different now, because if you read carefully, the phrasing is quite different. X now is the normal distribution they give you, a random sample of n observations is taken. So now, you don't know what is n. Given that 1% of the sample mean exceed 1.5. Now you're given a particular thing, sorry. Okay, let's do this. This one easy, this one from the question. Now x bar is x1 plus x2 all the way to xn over n. Because we don't know what is n, n observations are taken. We really don't know what is n. X bar is x1 plus x2 because this is a sample mean. Okay, we are interested in this distribution of x sample mean. Now, it should be quite easy. X bar should follow a normal distribution. What is the mean? The mean should be the same as x. What is the variance? Variance should be 20 over n. Variance over n. Make sense? Does that make sense? Because your x has a variance 20, x bar should be 20 over n. Okay, actually I should have covered that one. I shouldn't print that line for you. The most important line is the next line, which is in black. Printed for you already. Given that 1% of the sample mean, we should be able to translate this info 1% of the sample mean into a probability statement. Alright, 1% of the sample mean exceed 1.5 actually means that the probability that the sample mean exceed 1.5 is 0.01. Maybe first time you see a bit alien. Second time, okay, see it before but also cannot remember. Now you see enough, this kind of percentage kind of info, you should know that it makes perfect sense that you have this line. You want, actually this is from the question. 1% of sample means exceed 1.5 means probability of sample mean exceeding 1.5 is 0.01. They mean the same thing. They really mean the same thing. Actually, then what do we want at the end of the day? Well, all blank, best. Can continue, Can continue? Some of you say, got answer already, why, what's the unknown? Unknown is n, right? Unknown is n. But in this case, cannot use GC directly. How to use GC directly? Follow? You can't use GC directly now. The only thing you can do now is to standardize. Because you can't use GC because there's an unknown n. So standardize. Remember our friend standardize? So probability, how do we standardize? We practice, okay? Or map, do the same thing on the left and right. X bar minus 1 over square root 20 over n greater than 1.5 minus 1. Okay, I'm being a bit long-winded But that's the fundamental of standardizing. You do the exact same thing on the left and the right. Minus 1 divided by root 20 over n, minus 1 divided by 20 over n. Now this is now our standard normal. Correct? I'm not going to go through. You should have learned it in normal distribution. This is now our standard normal. Oh, like that. Okay, have to write already. Cannot be lazy. Probability Z greater then 0.5 root n over root 20 equals to. Now then, inverse norm, very happy. Can we inverse norm 0.01 now? No? Why cannot? Because of the inequality sign, this is greater than, we must change it to smaller than. So I'm a bit long-winded again. I say this is actually probability 1 minus z smaller or equals to 0.5. Then this one can be lazy. Can. What is the same thing? This one is that. Like that. Okay. So now we can inverse norm. Alright, because you know you want this probability, this side to be 0.99, you key the GC will tell you, oh now this answer probability Z smaller than 2.3263, you inverse norm, you will get this. Inverse norm 0.99, you get this answer. Correct? Therefore, from GC, this is from GC, okay? In case this is by GC, don't actually need to write but I just want to remind all of us by GC. Inverse norm, whatever. Okay? You will get this value. Then the rest is, copy, just copy. Now, it just happened that when you get n here, if you round off to 3SF, you will still get 433. But even if you, even if it's 43.29, you should also round off to 43, because n must be an integer. It doesn't make sense for n not to be an integer. Correct? You make n observations. N must be an integer. Now in this case, n must be an integer. Now you must be very careful with stats, because sometimes the value that you get must be an integer. Sometimes it need not be an integer. I give you an example. Expected value of x. If x is the CT2 question, if x is the number of siblings or other number of children under 12 in the family, okay, number of children under 12 in the family. So you have x, right? X is just number of children. Does expected value of x need to be an integer? Need or no need? Number of children, expected value of x, does it need to be an integer? You don't know, Don't know, right? Actually, no need. What does expected value of x mean? It means long-term average value, right? Long-term average value. You all learn in stats 1. Expected value of x is the mean, is the long-term average value. You have 2 children, 3 children, 0 children, 1 children, you take all of them and then divide by n. It need not be an integer. So in your CT2 question, there's an expected value question. All of us like to round off. Round to don't know what, I can't remember lah. You follow what I'm saying? Don't round off. But I must be very clear. But this case you must round off. This case you must round off. Okay, part 2. Okay, after this, we watch one video lah. Okay. Before we go to 6.5, come. Okay, next. What's the question? Question is this. Now forget part 1 already. Now we do part 2, okay? At most 1% of the sample mean exceed 1.5. Find the set of possible values. Be very careful, okay? Can I have attention? Thank you. At most 1%. So the first line becomes very important. At most means less than or equal. Yes? At most means less than or equal. So, we form this. The only difference between part 1 and part 2 is this inequality sign. At most 1% of the sample mean exceeds 1.5. Correct? Yes? At most 1%. Now the rest, actually the steps are more or less exactly the same, except that we must be careful to keep the inequality. So work with the inequality. If you are the type can get careless mistake all the time in getting the inequality sign wrong, I suggest don't jump too many steps. If you want to standardize and at the same time change the inequality sign, it is like that. Because we have done a lot of work just now already, right? So my suggestion is keep this one, just work with the left hand side first. And take this 1 minus like that. I did two things at one go. I did standardization, followed by changing the inequality sign. Take note, this inequality sign. Okay? Because there are so many inequality signs that we sometimes get confused. I rather keep these two, then later on tackle what happens next. Follow what I'm saying, right? Yeah? Now, then after that we do the normal thing. Okay? Be very careful, okay? If you were to move this thing across and then move 0.01 across, so you get probability z smaller than this, must be greater than 0.99. Now, you can inverse norm this, which is, inverse norm 0.99, which is we have done earlier, you will get 2.3263. Now, we have done this just now, we have already gotten 2.3263. This is equal to 0.99. Now, but if you want z smaller than this value to be greater or equal to 0.99, you draw the bell curve. Oops, sorry. What did I do? Now you want this area to be great. You know this, if this is 2.3263, you know this area is 0.99. But you want area, left bound area to be more than 0.99. This value must be greater than 0.99. Correct? This one now must be greater than 0.99. Now some of us do it quite, some of us quite clever spot pattern As long as you convert it to a lower bound, then your final answer here, why like that? Correct. Actually, there's one more step Actually, there is this one more line. Some of us do this. Must be greater than or equal to 2.326. Right? Actually, you can spot pattern because this inequality sign should follow this inequality sign. As long as, don't forget, as long as this is a smaller, then this must always be smaller, lower bound. Correct? As long as we ensure this is smaller than sign, this inequality sign should always follow this inequality sign. Once you get this one right, you will get answer. Actually, this is stats 4. I don't think I need to go through. Can? All right? Therefore, the question asks for set of possible values of n. Remember, set notation. When they ask for set of values, you must give in set notation, which is this. The reason why they ask for set notation is this. It's not very clear. If you give this answer, I'm sorry, I won't give you full credit. Why? You must recognize that n must be an integer. Because if you put real number here, that means you don't quite understand the problem. N must be an integer. Follow? Good? Great. Take a break.